Welcome to Easy Math and Circuit. In this video, I'll be showing you how to find the derivative of sin x using the first principle. And by first principle, we'll be using the step-by-step analytical method. Before you use the first principle to find the derivative of sin x, there are two things that needs to be noted. The first thing to be noted is the limit of sin theta over theta as theta approaches 0. So the limit of sin theta over theta as theta approaches 0 is equal to 1. The second thing to be noted is this trigonometry identity of sin A minus sin B. This is proven to be 2 cos A plus B over 2 sin A minus B over 2. These two things should be noted using the first principle to find this derivative of sin x. Now, given y to be equal to sin x, that means y plus delta y is going to be sin x plus delta x. Wherever you see x, you replace it with x plus delta x. In that case, y plus delta y minus y is going to be sin x plus delta x. Y from our question is the same as sin x. Now y is going to cancel out minus y, so we have delta y to be equal to sin x plus delta x minus sin x. Now dividing both sides by delta x, we are going to have delta y over delta x to be equal to sin x plus delta x minus sin x all over delta x. At this point, we have to compare this numerator with this our trig identity. Here we have sin A minus sin B to be equal to this. So we can simply say sin A minus sin B is the same as sin x plus delta x minus sin x. In that case, A can simply be said to be x plus delta x, whereas B can simply be said to be x. In that case, 2 cos A plus B over 2 is going to be 2 cos, our A here is x plus delta x, so we have x plus delta x, then plus B, that is going to give us plus x all over 2, then sin A minus B is going to give us x plus delta x minus x all over 2 all over delta x. So this can be written as delta y over delta x to be equal to, we have 2 cos x plus delta x plus s is going to give us 2x plus delta x all over 2, then sin x minus s is going to cancel out each other, then we have delta x over 2, then everything all over delta x. So we have delta y over delta x to be equal to 2 cos, we have 2x plus delta x over 2 here, so let's bring it out here. We have 2x plus delta x over 2. So these two can cancel out this, therefore we'll be left with x plus delta x over 2. In that case, we can simply replace this with this. Therefore we have x plus delta x over 2. Then multiply by sin delta x over 2 all over delta x. Dividing both the numerator and the denominator by 2, we have delta y over delta x to be equal to cos x plus delta x over 2 multiplied by sin delta x over 2 so we can also rewrite this to be equal to cos x plus delta x over 2 then multiply by sine delta x over 2, then divided by delta x over 2. At the beginning of the video, I said that the limit of sine theta over theta as theta approaches 0 is equal to 1. So in that case, as delta x is approaching 0, that means sine delta x over 2 divided by delta x over 2 is also going to be 1. In that case, as delta x approaches 0, delta y over delta x is going to approach the y over the x. And also, this also is going to be 1. Therefore, delta y over delta x is going to become dy over dx. And we have cos x plus delta x is going to become 0, so we have 0 here, multiplied by this is said to be 1, so we have dy over dx to be equal to cos x. Therefore, if y is equal to sine x, then dy over dx, which is the derivative of sine x, is equal to cos x. In my next video, I'll be showing you how to find the derivative of cos x using the first principle. Don't forget to subscribe to this channel. We'll see you in the next video.